Hi, this is Dr. Gilbert Eyabi. Welcome to Math 108, Introduction to Probability and Statistics at Anderson University, South Carolina. Today we will be looking at section 6.12 on counting from the text Discovering Statistics by the Hawks Learning Systems. Now let me just inform you that chapter 6 covers probability and counting. And today we're dealing with just the second part of chapter 6, which is counting. Now let's go in and begin to dig deep. 6.12.1, the fundamental rule for counting. I prefer calling it FCR, the fundamental counting rule. And the rule is very easy. It simply states that if E1 is an event with N1 possible outcomes, E2 another event with N2 possible outcomes, then the number of ways that these events can occur in sequence is N1 times N2. Beautiful. This principle can be applied for any number of events occurring in sequence, and we will see a couple of examples. Let's start. Example 1. Non-personalized license plates in the state of Utah consist of 3 numbers followed by 3 letters excluding I, O, and Q. So we have 6 events happening here. 3 numbers or 3 digits followed by 3 letters. How many license plates are possible? Beautiful. Now let's look at it. There are 10 digits, 0 to 9. Remember, there are 10 digits, not 9 digits, not 1 to 9, but 0 to 9. And if we exclude I, O, and Q, then we are left with 23 characters or 23 letters. So we have, look at the dashes, 1, 2, 3, 4, 5, 6. These are the 6 events we are about to execute. So we ask ourselves, in how many ways can we perform the first event? And in this case, the first event is to select a number or a digit. And we are not told that repetition is not allowed. So there are 10 possible ways to select the digit, 10 possible ways to select the next digit, 10 possible ways to select the next digit. So the first 3 events are done. The 4th character is a letter of the alphabet. It cannot be I, O, or Q. So there are 23 ways to select that, 23 ways to select the next, 23 ways to select the next. By the fundamental counting rule, to perform all 6 events, you multiply 10 times 10 times 10 times 23 times 23 times 23, and your calculator will give you 1216700. Beautiful. Example 2. You have a stack of 5 textbooks, English, history, statistics, geology, and psychology. How many ways can you arrange these textbooks on a shelf? Very easy. Solution. You start with 5 dashes. I always do that. 1, 2, 3, 4, 5. So these are the 5 textbooks. In how many ways can you place the first textbook on the shelf? There are 5 textbooks, so there are 5 ways. Once the textbook is placed, you don't take it out. You leave it there. You're left with 4 textbooks, 3 textbooks, 2, and then 1. So how many ways can you arrange 5 textbooks on a shelf? 5 times 4 times 3 times 2 times 1, 120 possible arrangements. And we shall see a couple of other examples close to the end of this lecture. Math is beautiful. Okay, now let's move on to the other counting techniques. But before we get there, we want to define the word factorial. I don't want you to see n factorial and think that the number n is exclaiming. No, this is not just an exclamation mark. In statistics and probability, this means factorial. And factorial of n is defined as n times n minus 1 times n minus 2 times 3 times 2 times 1. And by definition, 0 factorial is 1. Now, to break this down very easily, this is what we have. 5 factorial simply means 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3, and so on and so forth. So 5 factorial is 5 times 4 times 3 times 2 times 1, and that is 120. Now, for those of you who still use calculators, maybe tier 84 or tier 83, what you do is you turn on your calculator, assuming that you have battery in the calculator. You turn it on and you type the number 5 and you select math and then scroll to the right to probability, PRB, and then scroll down to number 4, which is the factorial sign. Hit enter and you should see 5 factorial on your screen, and hit enter a second time and that will give you 120. So that is how you find factorial. Now, if you are using Math Studio, let me quickly show you how to get that. So if you're using Math Studio, just start typing FAC for factorial, and you should see it right there, and select factorial, and right there between the parentheses, select 5 and hit return, and that should give you 120. As easy as that. Okay, that is it for users of Math Studio. Now let's move on to the next counting rule that is known as permutation. A permutation is a specific order or arrangement of objects in a set. There are n factorial permutations of n unique objects, just like we have 5 textbooks and we have to arrange the 5 textbooks on a shelf. The answer is just 5 factorial. Is that the only kind of questions we can get with permutations? No. There are more beautiful problems, and we shall see them. Example, to complete your holiday shopping, you need to go to the bakery, department store, grocery store, and toy store. How many stores? 4. If you are going to visit the stores in sequence, how many different sequences exist? This is just like the 5 textbooks that you want to place on a shelf. You want to visit 4 different stores. There are 4 ways to go to the first store, 3 to the next, 2, and 1. So that would just be 4 times 3 times 2 times 1, 24 ways to visit all 4 stores in a sequence. Again, kind of a boring example. So let's look at something that is even more exciting. And here we are. Permutations of n objects taking k of them at a time. The number of permutations of n unique objects taking k at a time is given as, I prefer this notation, npk, which is read n permutation k. So there are n unique objects, and I'm taking k of them at a time. There could be 10 objects, and I'm taking 3 at a time. And that is defined as n factorial divided by n minus k factorial. So if it was 10 permutation 3, it will be 10 factorial divided by 7 factorial. Now let's look at a quick example here. 7 permutation 2 would be 7 factorial divided by 7 minus 2 factorial, which is 7 factorial divided by 5 factorial. Now we can actually use technology to solve this, or we can do it manually. 7 factorial is the same as 7 times 6 times 5 factorial. All of that divided by 5 factorial, and I can cancel out the 5 factorials, and I'm left with 7 times 6, which is 42. As easy as that. Or I could use technology. Again, let me start with calculators. Turn on your calculator. You type whichever number. If it was 11 permutation 2, you type 11, but since I'm dealing with 7, it will be type 7, select math, scroll to the right to probability, and instead of selecting factorial as we did the first time, select NPR. Hit enter, and then select the number 2, And on your screen, you should have 7 NPR2, and then hit enter the second time, and that should give you the answer for 7 permutation 2. For Math Studio users, all you do is you start typing N, and you should see NPR, and select NPR, and in there you want to put 7 comma 2, that means 7 permutation 2, and hit return, and that should give you 42. Very easy. Okay, that is beautiful. Now let me introduce you to a beautiful idea known as distinguishable permutations. If you are given n objects, and one of them are alike, n2 are alike, and so on and so forth, then the number of distinguishable permutations of all the n objects would be given as follows. Now, I do not want you to get scared with this formula, so I'm going to give you an example very, very quickly. How many distinguishable permutations can be made from the word Mississippi? How many letters are there altogether? 11. Okay, so according to the formula, I'm going to have 11 factorial. So let's go very slowly. 11 factorial. Now it says and one of them are like. So what does that actually mean? How many M's do you have in Mississippi? 1 M. So you divide by 1 factorial. How many I's do you have? 4 I's. Divide by 4 factorial. How many S's are there? 4 of them. Divide by 4 factorial. How many P's are there? 2. You divide by 2 factorial, and you can either use your calculator or Math Studio to compute 11 factorial divided by all of these. Now, let me just caution you, because students always make errors with this. Your parentheses are very important. If you're going to use a calculator or Math Studio to get this in one shot, you have to put the entire denominator in parentheses. If you put 11 factorial divided by 1 factorial times 4 factorial times 4 factorial times 2 factorial, the rule involved with operations known as the order of operations would give you the wrong answer. So always make sure that the denominator is in parentheses. Okay, we now come to the third rule of counting known as combinations. So we have the fundamental counting rule, we have permutations, and now we have combinations. A combination is a collection or a grouping of objects where order does not matter. Order is not important. And I should just mention this. The difference between permutation and combination, the big difference is this. When it comes to permutation, order matters. Order is important. Order is implied in the question. And we shall see a couple of examples at the end of this lecture and also in class. So order matters with permutation. Order does not matter with combination. For all of them, we are dealing with n objects, taking k of them at a time. So the big difference is order. Order is important with permutations, and it is not important with combination. So combination of n objects taking k at a time, NCK, which is read n combination k, or n chose k, n unique objects, and I'm choosing k of them at a time. And the formula is NCK equals n factorial divided by n minus k factorial times k factorial. For example, 7 combination 2 would be 7 factorial divided by 5 factorial, which is 7 minus 2, times 2 factorial. Again, if you're going to put this into your calculator, do not forget to use parentheses right here. But you do not have to do all of that. You can use your calculator and get 7C2 directly. What do? Turn on your calculator. Hopefully it has batteries. Type the number 7. Go to Math. Scroll to the right to Probability. Scroll down to NCR. And hit Enter, of course. And then type the number 2. And on your screen, you should see 7NCR2. And then hit Enter, and that should give you the answer 21. Again, on Math Studio, start typing N and you should see NCR. So go ahead and select NCR and you want 7 combination 2 and hit return, and that should give you 21 directly. Okay, very straightforward. Okay, let's take a problem. In South Carolina's Carolina 5 lottery, a player selects 5 different numbers from 1 to 36 inclusive. So there are 36 numbers and a player selects 5 different numbers. If the numbers selected match the player's numbers in any order, the player wins. What do you notice? Order does not matter. So there are 36 possible numbers and you're selecting 5. Question number 1. What is the total number of winning combinations? And number 2, what is the probability that you would win? If I can find how many possible combinations are there, then the probability of winning is just 1 divided by the total number of elements in the sample space, which will be the total number of winning combinations. Okay, solution. And it's very easy. Once you realize that you are not in the sphere of the fundamental counting rule, and how do you realize that? You have n unique objects and you are interested in just k of them at a time. That tells you that you are no longer dealing with the fundamental counting rule. So you could either be with permutation or with combination. If order is not important, then it is combination, and your answer is simply 36 combination 5, which is 376992. If you go out there and buy just 1 ticket, what is the probability that that will be the winning ticket with the 5 numbers you have? Is 1 divided by 376992, 0.000003. You probably should just keep your money. In conclusion, I'm going to present a couple of problems directly from the Hawks learning system from your certification. Probably about 8 problems. So let's start with number 1. A value meal at Run Sub consists of a drink, a sandwich, and a bag of chips. There are 5 drinks to choose from, 5 types of sandwiches, and 3 types of chips. How many different value meal packages are possible? How many events are there? 1, 2, 3 events. The first event is to select a drink, a sandwich, chips. In how many ways can I select a drink? 5 different ways because there are 5 drinks, 5 different ways because there are 5 sandwiches, 3 different ways because there are 3 types of chips, and by the fundamental counting rule, 5 times 5 times 3, 75 different value meal packages are possible. Question number 2. A person tosses a coin 16 times. In how many ways can he get exactly 15 tails? 16 times, combination 15. And the answer is 16. As easy as that. You do not have to write out the entire sample space just to solve this one problem. The answer is 16 combination 15. That's how easy permutations and combinations can make some of this thing look. Example number 3. This one is a little challenging, so make sure you follow me, okay? You are getting a lineup ready for a school kickball game. You have 6 girls and 6 boys. The rules state that each child must kick the same number of times and alternate girl, boy, or boy, girl. How many ways can a lineup be made for one round of kicking? Solution. Option 1. Let's say we start with the boy. How many ways are there to select the first boy? 6. I alternate. The first girl, 6. The next boy, 5 ways. The next girl, 5. And I keep alternating until every child kicks once. And this completes the first lineup. But I do not have to start with a boy. I could have started with a girl. If I did that, then there'll be 6 ways to select the first girl, 6 ways to select the first boy, 5 ways to select the second girl, 5 ways to select the second boy, and so on and so forth until every child kicks once. Or stands for plus. So I could either start with a boy or I could start with a girl. If I started with a boy, then 6, 5, 4, 3, 2, 1 is 6 factorial. The girls will be 6, 5, 4, 3, 2, 1, 6 factorial. So it's 6 factorial times 6 factorial. If I started with a girl, it will be 6 factorial times 6 factorial. I could either go option 1 or, which is plus, option 2, that will be 6 factorial times 6 factorial plus 6 factorial times 6 factorial, and my answer is 1036800. So these are how many ways a lineup could be created for just one round of kicking. That's interesting, and it is a beautiful problem. Okay, example number 4. This one is very easy. You are ordering a new home theater system. You need a TV, surround sound, DVD player, 16 TVs, 22 surround sound, 19 DVDs. 3 events, 1, 2, 3, 16 times 22 times 19, 6, 6, 8, 8. Example number 5, evaluate this expression. You can either use your calculator or you can do it manually. Very straightforward. Example number 6, evaluate the expression 10 permutation 4. Again, you can use your calculator, you can use Math Studio, or you can actually do it manually, and the steps are here. Example number 7, and you see this very often. Simple arithmetic involving permutations and combinations. Evaluate 12P9 divided by 12C6. Just use your calculator or Math Studio. Do not forget, the numerator is permutation and the denominator is combination. That should give you 86400. And lastly, number 8. The newly elected president needs to decide the remaining 6 spots available in the cabinet that he or she is appointing. There are 11 eligible candidates for these positions. How many spots does she want to fill? 6 spots. How many candidates does she have? 11 candidates. So there are 11 candidates, and she's going to be selecting 6 of them to occupy these 6 spots. Obviously, we are no longer in the realm of fundamental counting rule. We are either in permutation or combination. Next, we have to check if order matters. Yes, where rank matters. So how many different ways are there? Because rank matters, my answer is just 11P6. And your calculator or Math Studio gives you 332640. And that brings us to the end of our lecture on 6.12 counting. We will spend class time to solve some more problems on hogs and enjoy the beauty in math. Thank you, and God bless you.